Simcenter 3D now enables you to output a critical speeds map for rotor dynamics that is part of the API standards for the design of turbo machines. Critical speeds of a rotating system are computed by using a complex modal analysis. They are found on a Campbell diagram at the intersections of the eigenfrequencies with the first-order line for a simulation computed in a fixed reference frame. They are influenced by the parameters of the model, for instance, the stiffness properties of the support. To directly access the first critical speeds, a results probe can be used as shown here for the first, second, and third critical speeds. To build a critical speeds map, use a parametric model. Here, the isotropic stiffness of the bearing is the parameter of the simulation, so no damping is defined. The next step is to define the parametric study in Simcenter 3D Design Space Explorer. Pick the parameter of the simulation and its range of variation. Select the results probes of the critical speeds, the required iterations, and the values of your bearing stiffness. A critical speeds map is obtained by representing the evolving critical speeds as a function of the bearing stiffness. A critical speeds map can be used to predict the critical speeds in the operating range. If the turbo machine operates at 3,000 revolutions per minute, engineers can see that using a soft bearing with a low stiffness ensures the critical speeds are less than the operating speed.